Title: Accelerating Java Microservice Deployment with AI-Driven Dockerization. Hey everyone, and welcome back to the channel. If you're a software engineer or an IT student diving into the world of microservices, you know the power of Java and Spring Boot. But you also know the challenges, especially when it comes to packaging these applications into Docker containers. It often feels like a bottleneck, doesn't it? Manually crafting Docker files, endlessly tweaking for size or performance, sometimes even sacrificing security for convenience. Well, what if I told you there's a new, smarter way to streamline this process? A way that leverages the incredible power of generative AI to optimize your Java microservice deployments? Today, we're going to explore AI-driven Dockerization, a revolutionary approach that transforms how we build and deploy Java applications, making them faster, smaller, and more secure. Get ready to accelerate your CI/CD pipelines. So, why is Dockerizing Java microservices such a common pain point? Unlike lightweight applications written in Go or Node.js, Java applications, especially those built with frameworks like Spring Boot, tend to have larger footprints. The Java Development Kit, or JDK, is substantial, and packaging a fat JR with all its dependencies can result in surprisingly large Docker images. This leads to slower build times, increased storage costs, and longer deployment cycles. Furthermore, developers often use generic Docker files, which might not incorporate best practices for security, like running as a non-root user, or for performance, such as optimized JVM settings for container environments. It's a constant balancing act between image size, build speed, runtime performance, and security, often relying on trial and error or outdated knowledge. This manual, iterative process is ripe for automation and optimization. This is where generative AI steps in. Imagine an intelligent assistant that understands your Java project, its language, its framework, its dependencies, even its historical performance data. This AI can then analyze all these parameters and recommend, or even directly generate, a highly optimized Docker file tailored specifically for your application. It's not just about automating what you would do, it's about doing what you should do, but perhaps wouldn't have the time or expertise to figure out on your own. AI-driven Dockerization promises smaller image sizes, faster build times, enhanced security postures by incorporating best practices like multi-stage builds and non-root users, and ensuring consistency across all your microservices. It's about moving from manual guesswork to intelligent, data-driven optimization, drastically accelerating your deployment cycles. Let's visualize how this AI-driven process fits into a typical development and deployment workflow. It starts as usual. A developer commits their Java microservice code to a Git repository. This commit triggers your CI/CD pipeline. The first stage remains familiar. Your Java application is built, perhaps using Maven, producing a runnable JR file. But here's where the magic happens. A dedicated pipeline stage kicks in, invoking our AI recommendation engine. This AI analyzes the built artifact and project metadata, then generates an optimized Docker file. Only after this intelligent recommendation does the pipeline use this new, optimized Docker file to build your Docker image. Finally, this lean, secure image is pushed to your container registry and deployed to your target environment. This seamless integration ensures every deployment benefits from AI-powered optimization. To illustrate this concept, we've prepared a simple, yet realistic, Java Spring Boot microservice. It's a basic Hello World REST API, built with Maven, responding to a/API/hello endpoint. While seemingly simple, it represents the core structure of countless Spring Boot applications powering today's distributed systems. Our project structure includes the pom.xml4 dependency management, the AI-Optidoc Java application.java defining our endpoint, and a basic application.properties file. This modest application serves as the perfect canvas to demonstrate how AI can take a standard Java project and elevate its Dockerization from good to great, tackling issues like redundant dependencies and unoptimized JVM settings that often plague even small Java containers. It's the ideal candidate to showcase the benefits of AI-driven optimization. At the heart of our demonstration lies recommend_dockerfile.py, a Python script that simulates the generative AI engine. In a real-world scenario, this script would interact with powerful LLMs or custom AI models. It would feed them context like your Java version, Spring Boot version, Maven dependencies, and even your desired optimization goals, whether that's the smallest image size, fastest build time, or strictest security posture. Our demo script, while simplified, embodies this intelligence by generating a dockerfile.recommended file with predefined best practices. It's programmed to think like an expert DevOps engineer, applying multi-stage builds, strategic layer caching, non-root users, and JVM optimizations, all without manual intervention. It's about leveraging computational power to distill years of Docker and Java expertise into an automatically generated, optimal Docker file. Now, let's pull back the curtain and examine the Docker file generated by our simulated AI, dockerfile.recommended. The first key optimization you'll notice is the multi-stage build pattern. This Docker file is divided into two distinct stages, build and final. The build stage, as its name suggests, is where your Java application is compiled and packaged. It uses a Eclipse 17 JDK focal base image, which includes the full JDK necessary for compilation. A critical AI recommendation here is the intelligent use of Docker's layer caching. Instead of copying all source code at once, the pom.xml is copied first. This allows Maven to download dependencies, and if your pom.xml doesn't change, Docker will reuse this cached layer, dramatically speeding up subsequent builds. Only then is the rest of your source code copied, and the application is packaged into a slim, executable jar. This thoughtful layering saves significant build time. Moving on to the final stage of our AI-optimized Docker file, this is where the production-ready image is crafted. Crucially, it switches to a much smaller Eclipse 17 JR focal base image. The Java Runtime Environment, JR, is all that's needed to run the application, saving significant image size compared to bundling the entire JDK. Another vital AI recommendation for security is the creation and use of a dedicated non-root user, Spring in our example. Running your application as a non-root user drastically reduces the attack surface. The AI also intelligently includes expose 8080 to declare the application's listening port and, perhaps most importantly for Java, sets up Java_OPTS environment variables. These parameters, like XMS, XMX, and plus use container support, are crucial for optimizing JVM memory usage within containerized environments, preventing out-of-memory errors and ensuring efficient resource utilization. Finally, only the build JR from the build stage is copied, keeping the final image lean and focused on runtime execution. The true power of AI-driven Dockerization comes to life when integrated into your CI/CD pipeline. Our .gitlab ci.yml demonstrates this seamless automation. Instead of manually updating Docker files, the pipeline itself takes charge. We have a build Java stage, where Maven compiles our application, archiving the resulting JR artifact. Immediately following this is the AI recommend Docker file stage. Here, our Python 3 recommend_dockerfile.py script is executed. This script reads the project context, even though simulated, it conceptually does so, and generates the dockerfile.recommended. This AI-generated file then becomes an artifact passed to the next stage, Docker build push. This stage logs into the Docker registry, uses the AI-recommended Docker file to build the optimized image, and pushes it. This ensures every single commit benefits from the latest AI